And so can you tell us a little bit more about your grad program you're in?
So I'm in the computer science PhD program, and the School of Computer Science is like the complete like department, and within it has 7 different like departments,
Okay.
and I'm in the computer science department, which is
nice.
like it's a bit confusing because like School of Computer Science and then computer science department, but
what are the other departments? Like just like what like not all of them, but like what's
AI, is that one of them or something? Like AI ML shit?
Yeah, there is ML, and then there's comp bio, language technologies, so like NLP stuff,
Okay.
and robotics, HCI. That's
Damn, there's a whole department for that? Damn.
Wait, what's
That's
HCI?
human computer interface. Like the Neuralink that
Oh
that
shit.
type shit.
Okay. That's insane.
there are 2 more that I'm forgetting.
The bullshit ones.
uh
The HTML department.
Web design.
The web design department.
Wait, I actually know this. I should remember at least one more.
That's all right. No one's gonna see this, bro. It's fine.
Yeah. Anyway, there are 7 departments, so I'm in the computer science one.
Okay. And then what's your specific like lab or project or focus or whatever?
So I guess there's kind of like two main, kind of generalizing, but 2 main divisions within CSD. So one is theory, the so-called theory A side, and they focus on algorithms and computational complexity. And theory B, which is what I do, and they focus on programming languages, type theory, and type systems. So the more logic side of computer science. And so roughly what I do is, how do I say this? Devise methods for check to know that what you're doing is right. Basically, program verification. Like developing frameworks to ensure that you're actually writing what you think you're writing, basically.
So if I do like an if statement or like use the like additive operator, like it actually does that, or is it like more macro than that? Or micro, I guess.
Like the difference between the sequence of logical statements and the actual code. Like what exists in an idea.
Like you're on the right track. It's basically like if I give you like a piece of whatever, like C code, right? How do you even describe what it's doing? Of course, there are informations of like having a comment that says, it does blah blah blah, but it's pretty informal, and you're most likely a lot of times you're gonna make mistakes doing documentation like that. So the idea is first have like a specification of like a formal specification of saying, well, like what are the allowable things that what can I describe about this program, right? And the other part is to actually come up with rules or like lemmas or theorems that tell you if you write your code in such a way, then these formal specs will follow.
Oh, interesting.
So you're almost doing like math. Like I guess computer science is math, right? But you're like you're trying to prove certain things about what can be like what you can extract from code.
Right. It's basically like, I guess in a very basic sense, it's just telling you like what programming languages are, like what do they even mean in the first place, right?
Yeah.
Okay.
Like you said, describing like what that code, like if you wrote some C code, you want to describe what it does, but like instead of describing it in English, because like English is kind of informal and not exact, you're describing it in math.
Exactly.
Very interesting.
You don't sound convinced.
Yeah, that's really interesting. Yeah, you're like a mathematician, basically.
Yeah, dude. Higher level CS is like all math, dude. I feel like.
Yeah, we do use a lot of math. I mean, yeah, it's cool. Cool sometimes. It's also pretty annoying for that reason. Like, people in this field invented like branches of math basically to solve these hard programming languages.
Or those branches like rooted in like, I don't know, calc and algebra, something like that, or what? Are they like actually new?
Like, it's more connected. Yeah, I guess you can say it's analysis types, like topology. Like domain theory is a lot of topology.
Okay.
Wait, did you ever study the halting problem? Did you have to like, is that like within the domain of what you study?
That's kind of like, I guess that's the old, like it's kind of an older field than what I study. Because computability it's pretty old, right? And
Turing or something.
there are only two things, like the two observations you make about incomputability theory is whether a program halts, right? That's the only observation you make. And I guess for us, what we care more about is how things like behaviors at higher type, so to speak. So imagine if you have a program that has type Boolean, then the only things that you can tell about that program is whether it returns true or false, right? So a big question is, if you have a function, right, then what do you ascribe to it as its set of behaviors? So that leads to like the whole field of logical relations and related techniques of how do you describe behavior of functions, or functions that take in functions and return functions and so on.
Like what's their type?
Like what set of behaviors can you expect from that?
Oh, I see. Okay.
Wait, what's the type of programming where functions are passed into functions? There's like a name for it.
Nested? Is that what you're talking
about? No, functions into functions that returns other functions.
Like the general term is higher order functions. Like if you have like a function that's from int to int, that's a first order function. But if it's like an int arrow int to int, that's a second order function, and so on.
Gotcha.
Have you done any like software, because you're a CS major, have you done any like CS internships while you were like studying CS?
Yeah, I did 2 internships. The first one was in Boston. It was for a startup. What did they do? They did like SAT test prep, like a platform for prepping for standardized testing. And I did, I wrote an algorithm to I don't know if I told you about this, but I wrote the backend for like an app that like you can take a picture of like a known piece of like test bubble sheet, and then extracts the answers you put in, basically. Like, you know how in the ACT,
like a camera-based Scantron, like
yeah, Scantron, yeah, that's the thing.
Like image processing.
Yeah, like yeah, very basic image processing. So that's what I did freshman year, and sophomore year I did there's some networking stuff, like how to accelerate the data plane. Yeah, basically, like how to packets really fast. That's what I did. Yeah, and that was in C++. And so I think it was that time that I realized I really didn't want to do this after I graduated. So I started thinking about applying to grad school, and that's I started like doing research and becoming interested in all this stuff.
Do you want to, like, now that you're in grad school, do you want to like continue it, do some postdocs, or are you like ready to get out and like try the industry again?
That's a very good question. So yeah, I think first year or so I was like learning a lot of stuff. Like it was pretty good. And this year it's been a bit rougher because just trying to write down our results, and it's not as much learning new stuff. So sometimes I think, man, it would be pretty nice to just like have a normal job. Just write some code that you don't know if it's really right, but it works most of the time, and it's like call it a day.
Yeah, that sounds about right.
But yeah, I think you kind of like have stages of how into your work you are, and this is one of those points where I just need to like
write it out.
Just write papers basically. So it's not as exciting, but I think when I start like actually doing new stuff and learning about new things again, then it'll be more exciting. Yeah,
for sure. I mean, industry is definitely the same way. There's definitely projects that you're like excited about, and then they'll either like die off or it'll end, and then you like put on some shit and you're like, oh, I don't want to do this shit.
Yeah.